Right, so this question is minimum absolute difference in BST. So you are given root over BST and then return the minimum absolute difference between the value of any two nodes, right? And this is pretty straightforward, right? The tree is already BST, so it's going to be what? I mean, this is going to be sorted, right? So it's not randomly put in the tree for the value, right? So again, like if you want to find the minimum difference, it's going to be what? Your current node and then your parent node, right? So you are not going to say so let me just draw it. So you are not going to say, okay, I have this the minimum node here, and then you have the second minimum node here. So this is not a lot because the BST is already put it in order, right? So the only way you have to do is what? You want to find out the what? Your current node and with your parent, and this is going to be the minimum, right? So the minimum is going to be 1 here and then 1 here, right? 2 minus 1, and then 2 minus 3 is going to be -1. But we are talking about the minimum absolute difference, so it's you have to what? The absolute, right? And let's just look at this, and then it's going to be exactly the same thing. So 1 minus 0, right? 1 minus 0 is going to be what? 1. And then this is what? 48 minus 49, right? And this is what? -1. And then this is 48 minus 12, and this is like 36, but we actually ignore the value. And what you have to do is what? You can just using the InOrder traversal to just traverse the entire tree, and then you want to find out the current node and then the previous node, the difference between the current node and then the previous node, right? So what I need is what? The public void, right? And I'm gonna say InOrder traversal, and then for this is gonna be tree node, no? And if the node is actually null, then I have to return, right? And then I can just what? Traverse my left, and then I traverse my right, but I need to know like the difference, right? So if you want to know the difference, I need another node, right? So I'm going to say integer. You can say prev, right? So I'm going to initial prev equal to null at first, because in the beginning the tree node doesn't have the previous one. And then if a prev is not equal to null, which means there is something, and then once the first tree node, right, you want to assign the previous to the current node, right? And then I need to record to have a record for the minimum difference. So it's going to be what? I'm going to say integer the max value. So I will just keep mean value for the current node and current node value minus the previous node value, right? So it's going to be what? Result equal to max.min result, and then it's going to be what? Current node value minus previous node value, right? But I already assigned the previous to integer, so this will be it, right? So once again, I'm going to just go over. Also, I need to call this value, right? I need to call this function. Sorry, call this function and return result, right? So this is entire solution. So I I create a previous integer, which is going to be what? To declare my previous value, and once I have it, I will have a current value, and I will just subtract to get the difference. And then this will be pretty much to find out the minimum difference, because if the current node is actually root, right, you won't assign, you won't get into the if statement, because the previous is actually equal to null. But once you traverse the left or traverse the right, the previous will assign to the current node, right? And then just pretty much is like this. This is the current node, right? And then you go on left. But once you go on left, right, you assign the prev to 4, and your current node is what? 2, right? So this is the entire idea, right? So let me run it. And okay, not about, sorry. And if okay, so this is pretty much it. Right, submit. Alright, so this is entire solution. For the time and space is pretty straightforward. This is a space constant, and the InOrder traversal is all of n, right? Traverse every single node, and yeah. So peace out, bye.